call me old-fashioned, but I think if you're a software engineer and you're writing networked applications, you need to understand and be comfortable with the socket interface. So I'm not going to argue that the socket interface is the best designed interface that ever was, the best designed abstraction that ever was, but it is one of the most successful abstractions of all time. Basically, this is going to be our standard, almost universal way to get access to network functionality. If you don't realize that you're using the socket interface, that's just because there are abstractions between you and it. And sometimes those abstractions are not going to do exactly what you want. And so you need to be able to peer under the hood and use sockets directly. Okay, rant over. What is this exercise? Basically, you're going to write a short program. It's going to bind to a port. It will use UDP for simplicity. And then you'll use another program. I'm using Netcat here. You may use NCAT on Windows or Telnet. A lot of programs will do this. Basically, enable you to send messages to a destination. Here we're using localhost and the port that I'm going to bind to, that I've bound to in the background for the demo. Okay, and then what happens? Well, if you write a message here, your server should just shout it back and send. So very straightforward, but I want you to use the socket system calls. So I'll tell you what they are, because there's not that much pedagogical value, I feel like, in just like burrowing through and trying to figure out what they are. You want to open a socket. The socket system call for that is, shockingly, called socket. Okay, so this is the thing that's ultimately going to be called on your system, at least if you're using a Unix drive system. If you're on Windows, it's going to be similar, but not specifically this. I mean, Windows doesn't really have system calls per se, but it'll be something that's equivalent to this. You're going to open up a socket. Okay, I won't tell you exactly what kind of socket, but you can look through here. I've told you that we're going to use localhost, so that's the hint that we're using an internet socket. Is that too much of a hint? Hopefully not. An internet socket. You could do exactly the same thing with a Unix domain socket. That's going to be something for another video. But an internet socket, and I've told you that you should use UDP for simplicity. So that's the socket you're going to open. By the way, this is the system call, but you're probably not going to consume the system call directly, unless you're using C. If you're using a language like, let's say, Python, which I'll use for the sake of the demo, you're going to have a library which exposes to you the same functionality. So I like Python for this reason. Its socket module here is only a very thin wrapper around the socket system calls. So you can call socket.socket, and it has exactly the same, well, not exactly the same because Python's object-oriented, but it's got a very, very similar interface. It's just a thin wrapper around the socket system call. Now, depending on your language, you may have a thicker or thinner abstraction. But basically, for the purpose of this exercise, please just use whatever is the lowest level abstraction that your language provides. Okay, so socket to open a socket. Once you have a socket, did I say you need to bind to a port? There's a system call called bind. You can look that up yourself. Once you've bound to a port, you want to receive messages, right? You're gonna shout back the message, so you're gonna receive one first. Now, this is UDP. So there's no connection, which means you could be receiving a message from anybody, and you need to send the message back to them. And so there's a specific variant of receive. The receive, instead of using, maybe I'll show you this one as well. We can look at the receive man page, but what we actually want to use is this receive from system call. Now, again, if you're using something like Python, you're going to have to find how to do a receive from. Now, Python implements this as a method on a socket object, because Python's object-oriented. If it's the system call, you'd be using file descriptors. If you're using whatever random language, you're going to use whatever thing that random language does. But effectively, you need to use a version of receive, which also tells you who sent you the message. And then you're going to send to them. You're going to send to them. So you're going to use a version of the send system call, where you can send to someone. Right, so that's it. Those are the system calls you're using. And, it should be like 3 lines of code or something. This is a warm-up. but take your time. I'm not saying you're not going to have issues. Obviously, you need to use these system calls correctly, but hopefully, it should give you a sense that this is a powerful API. It's doing a lot of work for us, and once you get the hang of it, it should be pretty intuitive. All right, so go ahead, implement a little server that receives a message and replies to that message in a kind of shouty way, or whatever fun way you want. It's an Echo server. All right. I should be pretty comfortable with this stuff, so I'm just going to try and bang it out in one fell swoop, no plan, whatever. Let's see how we go. Shouts. Okay, so I'm going to use this socket library I mentioned. I do like the kind of respect for the system call interface that Python shows here by just putting a thin wrap around. Like, I want to be able to take my knowledge from language to language. I don't want to relearn your slightly better API. I'll just use the worst one that I already know. Okay. So what are we going to do? We're going to construct a socket. And I need this to be an iNet socket. You can read either the man page or the Python module details to see what this is about. But basically, I want an IPv4 socket. Yes, I'm running this locally, but I run a Braxis using the internet interface. Right? So I'm going to end up connecting to, sending messages to the server via the loopback interface by sending to localhost. But this would equally work if someone was sending me something over the public internet. Okay, so it's an internet socket, and we want to use UDP. The way to indicate that is by saying sockdgram. Again, I know this because I know exactly how to write this as well. iNet, dgram, and so on, because it's exactly the same as the socket system call interface. Right? Again, man2 socket to see what this is about. So this should give me a UDP socket now. Okay, I need to bind. I'm going to bind to an address. I need to provide the interface as well, not just the port, but I can use this special IP address to say any interface. Doesn't matter where it's addressed to. Okay, as long as it's gone to this machine, it doesn't matter. I'm bound to that. All right. What ports? I'll just make up a port. So now I've bound. I'm a server, which means I'm just going to run forever in a loop, receiving messages and responding. Right? That's the lot in life of a server. You run forever. I'm going to receive messages from people. And the reason is to make it clear that I'm using receive from instead of receive is because this is UDP. I'm just an open inbox. There's no connection. I'm not waiting for a connection, doing a handshake, establishing with whom I have this connection, and then just receiving definitely from them. If this were TCP with a connection, then I would just use receive because I know who it's coming from. In this case, I'm receiving from. Now, in some situations, you may want to ignore some of the messages that are showing up in your open inbox. In our case, we're just going to reply to everyone by shouting. So we're not going to do anything with the sender argument, other than send back to them. All right. Oh, for receive from, I need to provide a buffer size as well, which is it's kind of funny in Python because it's not really relevant, but I'll just use a full 4K page here. Look, this particular argument doesn't really matter. If it were too small, then some messages would get truncated in the case of UDP, because a whole datagram would show up, and you wouldn't. You're effectively telling the system call that you're not able to take all of it. By saying 4096, we're going to get any size because it's only going to go up to 1500. Right, these are details that are not germane to this particular problem, but you may be interested to research them further. Okay, I've received from, and so what am I going to do? I'm going to, well, for diagnostic purposes, let's print out that I received message. Now, message is going to come back as bytes, so I guess I need to decode that as if it were UTF-8. In order to be able to print it. I mean, otherwise it's just going to print out as a byte string, which we'll be able to read. It's no big deal. But to exactly make it a string, we'll decode it as UTF-8, and let's also put the sender in here. Now, sender is going to be a tuple in Python, a pair of things, both the IP address, which is going to end up being localhost, and the port. Okay. So now I want to send back, which I'm going to do with send_to. Send_to requires that I use send a message to the sender. Oh, and I want the message to be shouty. That's the whole point of the shout server. If I forget that, then why am I even here? Okay. Let me have a read through this because it'd be nice to just get it in one. Set up the socket. Bind to some port. Receive a message. I'm just making sure all the argument orders are correct. Printing should be fine. Send back in uppercase. Argument order is correct there too. Okay. Let's give this a shot. Okay, so we're waiting for something. Let's give it something. So with netcat, I'm going to use UDP. That's a gotcha. And I'm going to connect to localhost port 9999. Okay, and I'm going to type hello. When I press enter, I should see output on the left that says got the message hello from whatever random port netcat got. And send the message lowercase hello, and then on the right hand side I should see uppercase hello, and that should be it. That should be my program. Let's see, I'll press enter. There we go. Alright, I'll just make sure I can do it again so it wasn't a fluke. Oh, why don't I send some like I can send whatever bytes I want, right? Oh, that's interesting. Invalid continuation byte. Yeah, that's a little interesting, huh? That's because of the new line that netcat is sending at the end, I guess. Okay, I'm gonna ignore. I'm gonna ignore that for the sake of this particular exercise. We did what we wanted, and it's the message printing, which is not part of not the scope of the exercise. Oh, it's so tempting to fix this. Look, I'll leave it to you to fix this, just so that we don't get distracted. The core of this exercise, if you want to reflect on it, make sure you're picking up what you need to. The socket system calls are what are going to provide us with access to network functionality. And if we know how they work, they're very powerful. They do a lot of the heavy lifting for us. You may have abstractions in front of this, but a lot of the time those are kind of obfuscating. At least once you understand how the network system calls work, you'll find yourself, sometimes I write Golang, and Go, they've decided that they've got a better interface, which they do, but I don't know it as well yet. And so a lot of the time I find myself just tracing, that is to say, actually using a tool to see what system calls are being made by the Go standard library or reading the Go source code in order to see what is this function actually doing, what system calls does it actually call. Anyway, we'll do a lot more with sockets, but hopefully this was a good warm-up.